Tutup aja ya. Tarik dulu. Gitu. Check sound, check sound. Okay. Okay. Hello and greetings to all of today's webinar participants. It is such an honor to have you all join us for our biggest launch day event this year. I want to mention also that we are grateful because we are joined by participants from all over the world. So to those of you who are joining us from China, Taiwan, Singapore, Malaysia, Thailand, Vietnam, India, Philippines, South Korea, and other countries, we would like to say thank you for your time and enthusiasm. And to our friends in Indonesia, apa kabar dan selamat berpuasa. Usually we hold such event together with everyone in a large auditorium, but the recent COVID-19 disease has spoiled our plans in doing so. Instead, today we hold this special webinar to unveil to you our latest technology that we are currently working on. codename TOR-I, an abbreviation, or short for Teleoperated Robot Infinity 4.0. So before we begin, I would like to explain to you today's program. Today's program will be divided into 3 sessions. The first session will be a in-depth presentation about the TOR-I itself, how it works and what the features are, and also a look into how robotics and automation can give contribution to the human life and use cases in other countries, especially in Singapore. These 2 presentations will be carried out by my 2 dear colleagues here. We're joined by my friend on this side. Here he's Haikal, and then we have Ricky Lim joining us from Singapore. Hi, Ricky. Hope you're doing well.
Hello, can you hear me?
Yes, we can hear you very good. And lastly, after the presentation goes well, we will do a brief demonstration, and we will open a Q&A, question and answer session that you all can join and participate and discuss with us together. So the purpose of today's webinar is, first of all, is to give you a quick look inside of TOR-I and all of its intricacies. And second of all, this is going to be as a medium for discussion, because we would like to know what are your thoughts, what you think about TOR-I, and how we could better ourselves and better our designs. So with that being said, I hope everyone will have a good time today and hold great discussions with us about fighting together COVID-19 with technology, specifically robotics and telemedicine as the core technologies and core practices to fight COVID-19. So that's all from me, Hanif, your moderator today. So thank you and enjoy our presentation. So before that, I would like to introduce you all first to Ricky Lin. Ricky Lin is my colleague from Singapore. He has a multiple year experience in specifically robotics and automation practices in Singapore. So he will be presenting about how robotics do their job, how robotics can contribute in fighting COVID-19 in Singapore. So Ricky, the floor is yours. Please.
Okay, all right. Hello, good morning to everyone, and thank you for Hanif. Okay, you can hear me, Okay, I work at my office. Okay, basically most of the staff are working at home. Okay, from home. Myself, I come to office just to make sure that the system is working all well. Okay, good morning to everyone, and thank you to Infinity Group to allow me to participate in this launching of TOR-I. Okay, one of our great products to combat this COVID-19. Okay, the topic I'm going to discuss is basically more on application, how the robot in the reality. Let me show you my slide. Okay, let me show you my slide. Okay, probably I introduce you a bit. I'm the Director for Innovating Solution, which is a member of Infinity Group. I'm also the Executive Council member of AEIS. What is AEIS? AEIS is actually an association of electronic in Singapore. So we are involved in all the electronic industry in Singapore, right? Okay, let me show you what is the content that I'm going to discuss upon. Okay, I'm going to share with you a few things, okay, a few contents, which is a key measure taken by Singapore government to fight against COVID-19. I'm now in Singapore, so I show you what actually our government are doing. to combat this COVID-19. Then I move into the second part of content that I would like to share is how robots are helping to combat COVID-19. Okay, subsequently, I will show you how actually in reality, how people deploy robot, okay, in the context of Singapore and worldwide. The next thing, which is a lot of debate before, robot versus humans. So this is a 4 contents I'm going to share with you in a very short time. Okay, this in this webinar. Okay, let me touch about this is okay, the key measure taken by Singapore government to fight against COVID-19. All right, as you know, Singapore, we call it as circuit breaker at this time, and we are going to reopen. Government is going to reopen most businesses, although by phase. So we have a so-called protocol to set upon this, what we should do, and how we're going to prevent or against COVID-19, especially in the workplace. I'm putting this more on workplace instead of the whole country or what. Okay, let me share with you this. So first thing is the government. This source is from the Ministry of Manpower of Singapore. Basically, all the companies, organizations have to follow. First, to telecommute from home if possible. That's mean most of the workers, whoever, especially administrative job, sales, most people have to work at home. Even the circuit breaker has been opened up. Okay, then those are allowed to work in the company. Then we have to do a stagger work break hour. So let's say for my company here in Singapore, we have those engineers that work like Monday, Wednesday, Thursday, Friday. Then the subsequent will be on Tuesday, Thursday, that kind of thing. Okay, we do a stagger work and break hour as well. All right. Of course, after circuit breaker, we might able to go out for our meal and all this. But at this moment, we are actually having our meal at office. So we implement a shift and split team arrangement. We minimize need for physical touch point. Ensure clear physical spacing. Even in the workplace, we have to do a marking. So everyone have to make a distance, work distance at 1 meters. Sitting area also have to depart, which with a visual indicator show who sit at which area or working stand at which area. And the government also come up with those apps, support tracing systems. We call Trace Together app, safe entry visitor management system. Now, basically, most workplaces have to have a QR code, we call 2D code. For those visitors come here, we need to scan. So this is basically for the support contact tracing. Then, of course, the law to wear masks is still going on. Everyone have to wear masks. As a personal, then we have to observe good personal hygiene. Company have to set up cleaning and sanitizing workplaces, especially F&B, food or shopping mall, all this. They have to keep doing the cleaning and sanitizing. Cleaning disinfection agent must be provided. Yes, of course, we provide them. And again, back to the physical touch point, we try to even, for our side, robotic, we can do something there, here a lot of things, right? So regular temperature screening and declaration have been done. Here the travel advisory report and track unwell cases. This is for the company management. So worker, if they're unwell, they have to report to company, don't come to work. Okay, they have to take MC and they have to go to clinic and check. So of course, when go clinic, it's advised that all the employees should not clinic hop. So they have to go to particular clinic and don't hopping one-to-one. This is how the virus is infected to others. So this is a key measure we call safe management measure at workplace. So why I talk about this? Because this is how we can employ robotic to help against this COVID-19. All right. So my next slide, I'm going to touch about how robots are helping combat COVID-19. All right. So robotics is one of the key technologies to deploy existing human to fight against COVID-19. Of course, there's others more like AI, artificial intelligence. Then we have a software apps like that, like I mentioned, like Trace Together, Safe Entry, and all these. But robotics is something physical, visual. It really can work at the workplaces, okay, and in the field to kill, to actually disinfect the COVID-19. So how a country are using the robot, okay? So I analyze a few things, which is very logic and very practical to use. Okay, first thing is delivery robots. Due to contagious of COVID-19, it's safer if human-to-human contact is minimized. So in the normal situation, like we have to shake hand, we have to bring something, deliver the goods to one person to another person. So we are keep in contact. But now we use the robot to actually to deliver the thing. Okay, like what currently most organization company start to practice. They actually use robot to deliver medical supplies in hospitals. Okay, later I will show you some video, which is in reality, how they use that. Okay, so in Singapore, we have a lot of these foreign workers being quarantined due to coronavirus. So, so we deliver meals, collecting their laundering clothing, essential supply to patients, and this is all the delivery robots can be used, right? The next slide, okay, the next thing, telemedicines, provide care and treatments. Okay, this is very, robots are very useful in this part. So because it's patient, COVID-19 patient. So doctor, nurses, okay, those cleaner, of course, they try to avoid to contact with the patients. So how they do, we actually can build a robot, okay, to actually deliver medicines, or we send a so-called a computer, a PC, in front of them, instead of the doctor or nurses have to go in front of the patient. So this robot actually can talk to them on the monitor screen. Okay, basically, this save time, allowing possible contagious patient. Hey, sorry, can you see my screen again? Oh, I never move at all. Okay. Oh, the screen is not moving.
Yeah.
Oh, sorry. So do you never see the screen at all?
Yeah. Can you like rewind that bit, please?
Okay. I've been talking. So so now can you see the screen again? Are you able to see the screen?
Yes. Yes. Sure. Yeah.
All right. Okay. Very sorry. Okay. Let me start again. Oh no, I'm not going to start again. I just continue to show you the full screen that. Okay. Not move. The screen is not move.
It moves. It moves right now.
All right.
Yeah.
Okay. Okay. No. Okay. Move. All right. Okay. I cannot explore the screen here. Let me see. Okay. So this is the slide. Probably you missed. Okay. So the next thing is about the. Okay, I come back to the point. First, telemedicine and provide care treatment. So basically, as I say, the robot can serve to go to the patient and check their temperatures, sending the medicine, medical advice to the patients. Okay, so the next thing is robot is also now very popular, being used in hospitals, malls, school, workplaces as sterilizations and disinfection robot. So so what is a disinfection robot can be used? All right. So basically, we use a UVC. UVC is a UV light to kill or disinfect the virus. Okay, in the hospital, malls, schools, and workplaces. So this robot is basically emit the ultraviolet light throughout the area and kill the virus. Okay, of course, there's another type is we're using the disinfectant spray to kill the virus. Okay, my next slide. Okay, you see the, okay, you can see the slide. Okay, the next slide is about security surveillance. Robot are using also as a security robot. Okay, because nowadays many companies, especially during the circuit breaker or company lockdown, so we still need a security. So robot are using to actually to check, okay, to patrol the workplaces, and while the employee work at home, okay, work from home. Surveillance robots also used in the street, parks, public places to inspect safe distancing in place. Okay, this is interesting. In Singapore, actually, we are using this much. Okay, drone also is a flying robots, basically. So are using to actually to observe crowd, traffic efficiency, and make sure people wearing the mask, practice safe distancing, and they have camera. They can catch those people are doing the offense, do not wear masks, do not practice social distancing. So one thing, drone can fly, so they are not on the road. So there's any obstacle or the road are difficult to access, drone are able to do all the job, right? Okay, let me come to another point about how, okay, you all can see this video, right? Right? Can, all right. So first of all, let me show you a pre-COVID-19 deployment in Singapore. Okay, before COVID-19, we call this as a service robot, and being used in many places. Okay, and for industry, we call automated guided vehicle. All right. So here I show you some interesting thing that have been used in Singapore. Okay, first is probably you all cannot hear the sound. Okay, so this is one of the cities on one of the robot to check on the roadside, checking if any cars are offense. So the robot will take pictures or give the warning, right? So this is by Certis Cisco. The next slide. You can see this is the one that used for the, we call the Singapore food court. Singapore have many food courts. So this is one of the food court in the Marina Bay, Singapore. So here they actually use as a return tray robots. You know, Singapore, basically the manpower's labor crunch. So we use robot to actually help to ease this year. Okay, sorry, I don't know why my sister hand here. All right. So the next one also, before the COVID-19, we also have the, okay, we also have the robot beings. This is very cute one. You see, all the children also really like it. We can use as a advertisement and robot beings. Then the next one, you can see the picture that robot are using as a cleaner in Changi Airport, in our airport. And we have a robot deployed at the hotel. Okay, this is a Hotel Gents in Orchard. So they use a service robot to deliver their laundry, the ordering like drinks and all this to the room. Instead of this hotel service have to walk to the room, all right? This show the technology sophisticated being used in Singapore. And we have another robot that used in the hotel in Singapore. So you see they can actually deliver drinks to the rooms, and actually after delivery, they can actually request to give a survey to rate how is the service of the hotel. So hotel can collect the informations to know how is the service being provided. Okay, now we come into current COVID-19 situation. So many universities, institutions in Singapore actually are designing something useful to combat this COVID-19. So one of them is NTU, because Nanyang Technology University. They have been invented so-called using the AGV, this robot with collaborative robot arm. Okay, and they attach to kill all, attach sprayer to kill all the virus, combat the virus. So the next one, this is something have been implemented in. Okay, actually this is implemented in exhibition hall by ST Engineering. They use the robot to deliver goods or food, laundry products into the foreign workers patients center. So because you know Singapore, most of the patients are foreign workers. They've been quarantined. They've been stay into the like a big hall exhibition. So this robot are using to deliver those essential to them. So this is what currently practice. So this is one thing very interesting. Our national parks, we are using we call robot dog. Robot dog are actually, you see, this is a robot dog. Very interesting. So they are doing the surveillance, checking who do not practice safe distancing, and also taking temperature. Okay, it's possible, and they also send a warning by talking to the people, keep distancing and all this. Okay, again, this is a cleaning robot, okay, by Lion Bots. So basically, they use this robot to do the cleaning, so that those aunties, uncles, those cleaners, actually they try to avoid them to work. So they use robot to clean all the floor and all this. Even if the workplace are open, this robot are mostly required to do the cleaning. Okay, let me show you the rest of the part of the world. Okay, there's many video actually. You all can check. I just share you something. This is very interesting one. Like they use spray disinfections in the shopping mall. Okay, this is a supermarket. Then in Germany, they use a pepper, this robot as a communication robot to warning people, to guide people, to ask people to practice safe distancing. Okay, right. This is a few applications that I can show to you in this short video. Right. One thing I come into this. Okay, this topic has been discussed many times by many people, because people worry robot will overtake people's humans. So let me share with you my opinions. Is robot really better than human in terms of efficiency? Right? Hello?
Yeah.
You all can hear me? Okay, all right. So human superiority, basically human originality and creative. Okay, rapid retraining. So human can train everything very flexible, and human are empathy. All right. So we have a feeling, we have emotions. Okay. Human basically can evaluate the risk for unexpected events. Something that suddenly changed, like just now my system hand, I don't know how. So human, we can immediately solve the problem. We have to find how to solve the problem. But robot could be something you need to preset, right? So use equipment beyond specific limit. Okay, flexibility, again, human flexibility. Like let's say I drive a forklift. If program one and human is different. Of course, these are all the superiority and advantage of human. Then we come to robot. Why we use robot? Of course, precise repetitive motion. A robot can use for repeat job. Okay, and the accuracy. Okay, no doubt. They work the thing 24 hours, 7. They are very accurate and they can do things more precise than human. Human can be tired, but robot not tired. Basically, unless they have to charge battery. Okay. quicker response time, store and recall large amount of data and all this because we have brain, we have a computer, not enough, we add more git. Okay, then robot basically can do a lot of data, all right? So reason deductively, yeah, they work with a reason, the program that we set for them. This plus this is what, okay? Like human is different. Human is more like basically it's a emotion. I mean, based on the reasoning, experience and all this. But robot, we give them a program to do what to do. All right. Stronger. Yes, robot. We can build a very strong robot, whereby human cannot carry 1 ton or 2 ton. Robot can do all this. Even now, the collaborative robot hand, those robot arms, all this can do very heavy thing, more and more heavier. All right. Robot, we can put a lot of sensors to sense. Whereby human, we have eye, we have this a few sensor, but robot we can use a very intelligent sensors to do all the job. So I'm more like to show you what is the advantage of human and robots, and comparing in terms of manual work, labor, store, recording large amount of data. Yes, robot of course better. All right. So, but today we are going to face into Robotics. We are no longer comparing whereby human or machine are better, because we have integrated them both together. The brain of human with brain of robot. So this is the launch of TOR-I. TOR-I is what the topic that we are going to talk today. Okay, so without talking so much further, I would like to end my speech here. Thank you very much. So I hope this is useful to actually to start with our launch of TOR-I robots. All right, Hanif.
Hi.
I pass back to you.
Yep.
Because we have long webinar to go through.
Yep.
Okay.
Perfect. Thank you very much, Ricky, for sharing with us today.
Yes.
First of all, apologies for the technical issues. No worries, because we are going to share the video and all the presentation to you afterwards, after this webinar. So, but before we go into my colleague's presentation today, we're going to give you a short video explaining a bit about TOR-I. So please enjoy, and hope you guys can get some information out of it.
Memberikan kontribusi yang nyata dan aplikatif untuk membantu para sampai di sekitar yang berjuang untuk ke depan karena COVID-19 di Indonesia. Saya di sini sebagai tim leader dari Robotics dan Software. Kami memulai pengembangan TOR-I ini dengan memodifikasi produk kami sebelumnya, yaitu robot AGV atau Automated Garage Vehicle, yang kita modifikasi dengan penambahan IoT atau Internet of Things, sehingga robot ini bisa dikendalikan dari jarak jauh dan bisa digunakan untuk komunikasi secara real-time. Harapannya robot ini bisa membantu para pekerja sosial, pekerja medis, pekerja lapangan untuk menghadapi pandemi COVID-19.
Okay, so I understand that a lot of you guys have a problem in hearing the sound from the video. So apologies for that. We've provided a link on the chat room. So if you're curious or if you want to hear the audio, you can go down to the chat room and then you can click on the YouTube link and then you can hear the sound and watch the video repeatedly. So before we go to the demonstration session, we have another presentation about the TOR-I itself. And for that session, we have Haikal over here, which is the head of engineering from Infinity Group. He oversees both the design and also the development of the robotics platform. So without further ado, Haikal, please, the floor is yours.
Thank you very much, Hanif. Okay, I'm going to present the developments and the result of the mobile robot TOR-I. And then for this presentation, we call it the rise of mobile robot and telemedicine in the battle against COVID-19. So can we use this? Okay. So first of all, before we go into do the presentations, I would like to have disclaimer before. So this session, we would like to gathering a lot of information, receiving feedback from all of you guys. Maybe you guys came from a different sector. Maybe some of you guys came from the medical background, or maybe from an academic background, or maybe from industrial background. That's why we will very eager to have your feedback and your idea based on what we are presenting now. And then we also want to do to have a knowledge sharing. And then also we would like to share you some industrial POV, personal view, because we came from the industrial sections. Okay, without further ado, let's go to the next page. So because the COVID-19 pandemic, the situation, it has became a major stage for mobile robot and telemedicine's deployment. As you heard before from Mr. Ricky Lim said that Singapore and a lot of global nations are deploying a lot of technology that might aiding and battling the COVID-19 pandemic. So as everyone around the world tries to cope with the COVID-19 pandemic, healthcare workers are struggling to keep themselves healthy. But with that being said, it's a good time to remember the 3 Ds of robotics: the dirty, dull, and dangerous. These 3 points that really the robot can do well. So the coronavirus outbreak has highlighted the use cases for mobile robotics. I believe some of you guys have seen a lot of footage or video from Chinese government or maybe Korean government, maybe European nation deploying a lot of mobile robotics here and there, and they are successfully doing what we call what we like to say like monitor, disinfect, surveil, handles, and deliver materials. But none of available technologies nowadays provide such one-step solutions and both accessible for the country, maybe in Southeast Asia, especially in Indonesia. Okay. Maybe I'll give you some a little bit introductions about Infinity Groups, especially from the engineering team. We are a team of, I would say, young and energetic Indonesian engineers, planners, and programmers. So we are committed to give the best value and solutions to our customer by implementing the best practice. So we believe that our experience in bringing robotics, AI, and Internet of Things to industry, it is also possible to bring this remarkable technology to help solving one of our biggest problems right now, the spread of COVID-19. Okay, these presentations will be divided into several sections, and the first section is introductions of TOR-I system. As Hanif already mentioned, TOR-I is abbreviations of Tele-Operated Robot Infinity 4.0. So, okay. So the development of TOR-I is not really something that just came out in several weeks. So what we do here that we've been in the mobile robot industry for quite some time, and then I think starting from 2016 or 2015, we are trying to find a low cost and compact design for the industrial mobile robots. That's why in 2017 we successfully designed and deployed what we call the Clark AGV. The Clark AGV is simply like low cost robot, mobile robot that not only good in technology wise, but also accessible for certain layers of manufacturer. Because in Indonesia, as you know, that there's a lot of factory from like electronics, from the car manufacturer up to the shoes and garment. But those factories they don't have the same layers. So it's just different applications or maybe just different needs. That's why we came up with these low cost solutions. And then on 2018, the second generations of Clark was born, and then we do the industrial deployment for some factories back then. Okay. Up until 2019, the positive feedback from customers for compact and accessible design was keeping us encouraged to develop more and more. And then on 2020, COVID-19 major breakout initiate the beginning of TOR-I. So that's why what I'm saying is that TOR-I is based on the industrial mobile robot that we've been developed for several years ago. So this is the second generation of Clark. So this is the low-cost robotic, the low-cost mobile robot that I already told you. This is fully autonomous using the magnetic guidance and RFID. It is very common in industrial. Maybe from some of you guys, if it's not from the industrial sections, this is not very something that you see in everyday lives. But in industrial sector, it's quite common to see a mobile robot bringing materials here and there. So the idea came up, and why don't we utilize the robot to help battling the COVID-19? So this is one of the two applications that we've done in a factory. Haris, can you try to start the video? Okay. These small robots, very cute with the sounds of Mario Bros. Going from point A to point B, bringing materials and everything. It's actually the same concept that we are trying to implement in TOR-I. As you can see on the right side video, I don't know if you guys can hear the sounds or not, but if you can hear the sounds, actually the robot is playing the Mario Bros. Theme. So you can see on the right side of the video, you see that the robot is integrating with another equipment. There is the same concept as well that we can implement on the hospital. Let's say if Obviously, a lot of hospital in Indonesia don't have any automatic door, but certainly maybe in the next development we can find a way to develop those integrations. What we have done is actually bring those technology to the hospital use. Okay. Sorry. To the next. Oh. Okay. So this is the knockout parts. So basically, what I've said before, TOR-I is based on industrial robotics. It means that the part also from industrial equipment. So this is the very core parts of the robot. So you have motor, you have safety obstacle sensor, you have the network equipment, you have the industrial PC. Maybe let me put this way: for those of you, if you guys are not familiar with the mobile robot, you can just imagine an autonomous car by Tesla. It is basically the same system like the robot. So you have the motors, you have the controller, you have the network, and the safety sensor. So it is how to say, Hanif? Maybe the same size of robot, a smaller size of
smaller size of Tesla.
Smaller size of Tesla. Let's say like that. So those are the knockout parts there. And as you can, as I mentioned there, core parts are based on the industrial basic for most mobile robot. So what I'm trying to say is that the robot is assembled by the industrial part that have a certain standard for the industrial environment. So I think it's also suitable for the public places and this hospital environment as well, because usually actually the very basic of industrial design means that it needs to need to be good in handling the harsh environments of the factory. So that's why we have a very good confidence that the parts that we have used here is have a higher standard. Okay, so this is the main function and task of the robot that can the robot perform. So we call it 6-in-1 platform. So it means that we have 6 systems that can be done or that can be performed by the robot itself. So the first one, what we call the telepresence, is, as you can see, the term that I use here is not the telemedicine because it's not only for the telemedicine's job, but also it can be used on the factory. So that's why we call it telepresence. It means that the robot is working as an avatar.
Yeah, avatar.
Yes,
yeah,
I think
avatar,
it's quite term. I mean, yes, as an avatar. So bringing the people from the control stations to the remotely or maybe different room far away from the control room. So that's why you can propel the image of the operator, and also you can relay the information of what the robot see using the telepresence functions. And the same function there is also for the surveillance. Like Pak Riki already mentioned, in Singapore there's a lot of robots doing the surveillance job, and then TOR-I are expecting to be used for the surveillance as well. Transporting is very obvious. I don't think it's not common. And then the fourth function is the UVC disinfections, and this is also very common in this era, in the COVID-19 era. And then we can also have the temperature measurement using the thermal imaging. And then the last one is almost the same like UV disinfection, but this one is using the chemical substance, the spray disinfection. Okay. As I mentioned before, that TOR-I is basically a complete platform of robot with the 6 different functions. So I would like to say that the TOR-I robot in the middle is the main hub. I mean, the main controller, the core of the functions. And then it can be combined with the transporting card. You see on the right side, on upper right side, I have some description there that mention the main hub, no connectivity, hardware connectivity, and embedded connectivity. It means that If there's no connectivity, it's basically as simple as you put something on top of the robot and you let the robot go. That's it. And for the UV disinfections is basically have those hardware connectivity. It means that it can be connected through hardwire cable to communicate, to integrate with the robots. So the UVC disinfection will be having two types of mode, and then we will have the details in the next page. And the third one is pretty much the same like the UVC disinfection, but it's just a different method of the way we disinfect. And the last hub is what we call the embedded connectivity. So each TOR-I robot is pre-installed with what we call the Mavix Air software. So this is maybe to put it simple, it's like an OS or maybe like a main software that control everything from the robot, from the communication software, everything inside it. Maybe it's sort of like your OS, maybe like Windows or maybe like Linux. So this is the main function of the Mavix R. So the telepresence, the temperature measurement, and the surveillance. So as you can see that we have a very broad range of implementation. So we believe that TOR-I can be deployed in various scenarios, not just for hospital as a telepresence robot, but also can be used on public places such as restaurant, office, hotel, maybe like warehouse. Maybe you can see like IKEA, they have a lot, very big warehouse and very big showroom. That's why TOR-I might come in handy to help to disinfect, maybe for the surveillance job as well. And also, our team are very eager to explore new kind of possibility. Let's say like disinfecting passenger seats on aircraft. That would be a good idea to deploy the robot inside the aircraft because due to the compactness of the robot size, and then also the fully functional for auto disinfecting. Okay, so this is what example cases, the simple use cases on how TOR-I helping our medical staff. So as you can see that on the right side, on the bottom right side, you see the nurse station, and to the left side you get the patient ward. So the medical staff is operating the robot to help deliver medical goods or food or maybe like equipment, and then using our own developed communication software, nurses from station can communicate with other staff or patient inside the isolated ward or maybe like the HU or ICU. As you can see that this robot is operated by human, and we're going to further discuss about the functions about why the robot is still manually operated later on this page, but we have very strong reasons about that. So please, okay, this is the technical specifications. So the design was made by by our team to sufficiently leveling the heights of average Indonesian male. So the height is around 1.6 to 1.7 with the width of 500 millimeters or maybe like half a meters. That's what we try to design as compact as possible to have a good maneuver inside the hospital or inside a very small room like office and everything. As you can see on the left side, there's a table. For the specifications. So the robot payload is around 60 kg. It means that the robot can carry maybe goods or material up to 60 kg. And then the robot speed is around 35 to 40 meters per minute. So there's a good reason to limit the speed because the use of the method of how to control the robot is still manually. That's why we are trying to prevent any accident inside the environment that's been deployed, like say like hospital, because the safety is the first factor to be concerned about. And then they have also obstacle sensor. We are having we using the time of flight sensor. It's basically like laser sensor, and the other obstacle sensor we are using is the depth camera. So maybe for those of you that came from the robotic backgrounds, it's very common right now that we are using a depth camera. It means that the camera can sense the 3D perspectives of the environment just like human, because our eyes they have two eyeballs, right? The two eyeballs give you 3D perspective about the environment. The usual term is called stereo camera, using two cameras to obstruct or to construct 3D images. And that's the same principle that we do here in TOR-I. So for the camera, we have two types of camera inside the robot. The first one is front-facing camera with mic as well. It is solely for communication, but not limited to use as a navigation as well. And on top of it, on top of the robot, you can see that I don't know if you can see or not. On the top of the robot, we put what we call the 360 camera. For those of you guys, if you guys don't have not very familiar with the 360 camera, it's almost the same like Google Maps functions that you can see the street if you enter some place, right? Yeah, that's the same principle. Basically, you can see the whole 360 perspective from the camera. It's like you are the camera. It's like you are the robot, so you can have the presence of the environment. Yeah. And then you also have the display screen, obviously, and battery life. Battery life is 8 hours in operations, 3.5 hours if we are using the UVC module alongside the robot. The 8 hours operation, it is considered as the standard for the mobile robotics that we use in industry. You can check any other mobile robots there in markets. Usually they use the same parameters, like 8 hours in operation, maybe 8 to 10 hours. It depends on the workload. And then we use the lithium 24-volt 60 ampere hour with battery management system. For those of you that not very familiar with the lithium battery, it is basically the same battery that we use in electric vehicle. If you know that Tesla, maybe from BYD, it's the same principle, the same type of battery. Maybe like just a different material, like battery, lithium, nickel, lithium polymer, and so on. The charging hours, if you charge it from the very low voltage, you need 2.5 hours, 2.5 hours. And then, as I say, operating method is using the remote control with semi-auto intervention control. We will go into explaining more about that later on the next page. And also you have UVC module with 6 units of 36 watt UV control with the mobile app devices. And there's a good reason that why we are using the mobile apps and in the next pages, and also the medical rack capacity for transport foods or medical goods. Okay, the second section is the functionality of TOR-I system. So as I mentioned before, that one of the functions of TOR-I is surveillance. So TOR-I can be used as surveillance equipment for factory. As you can see that there's an image presentations there that the robot is monitoring all the workers inside the factories to maintain the COVID-19 protocol, because we believe that the effects or the byproducts of this pandemic is not something that temporary, but it's something that maybe last long or permanently. So that's why it will change a lot of standard that we already do here in all types of business aspect. So let's say, like, by using the surveillance equipment for factory, we are preventing crowding worker by giving warning or information to keep physical distancing using the audio video communications. And also we can use the TOR-I, one of the function is to detecting unmasked worker. This can be done in two ways. You can do it manually because this robot is obviously operated by a human. As long as the human is on the sides of the camera, then you can, how to say, give a warning to say, to remind the protocol. Or the more sophisticated way is to combine with the artificial intelligence functions. You know that AI is getting more popular there. Like Google, they have TensorFlow. Like IBM, they have Watson. Maybe like Microsoft, they have Azure. Those are the AI platforms that have been mentioned is quite popular in the world. So we can integrate those functions in AI, especially for the visual inspection, to do like facial recognition to see that whether the operator is using the mask or not, and then they can automatically detect using the AI. Okay, you see that there's a logo there with facial recognition on every workers there, and then there is a sign warning there that it means that maybe the worker is not using the face mask. Obviously, because the camera is being obstructed by the car, so that's why the system is identified as a false. Okay, let's continue to this. Yeah, and then the second options that we that we can do is for the thermal imaging. So it is basically the same like we do for body temperature measurement, but instead of using the standard non-contact digital thermometer, or maybe a manual thermometer, we are using a thermal imaging technology. So basically we combine the infrared and the camera to do the heat measurement. You see, if we are using the camera for the facial recognition, it means that we can specifically point the person and then get the data, the temperature data from the person itself. And then as long as the camera can detect the people within the certain area, it can detect up to 3 to 5 people. So one of the application that can get along with this thermal imaging is we put the robot on the entrance of the factory to maybe monitor all the workers that come into the factory, and give the specific information about the body temperatures to prevent any COVID-19 spreading. Okay, and then the last one, the third one is the telepresence functions. As I mentioned before, that each TOR-I robot it have an embedded communication software called Mavic-R. So the Mavic-R are the software that we've been developed in the previous month. So the software is allowing the operator on base station, on the central station, to communicate with people on different rooms and also perform various functions such as two-way video communications. So basically the same like Skype, maybe like Zoom, but this software is originally designed by us, so it is not related with Skype or everything. And then one thing that interesting is that we also installed the COM box. The COM box is a communication box, so that when, let's say, when the sound is not very good, so that the operator on the control system, control room can write an instruction, let's say a message on the screen. Maybe if you're talking about the hospital implementation, you can give the prescriptions or meal plan or emergency message and etc. It will be displayed on the screen facing the patient. And then the last one is voice generator and face recognition, and as an optional feature. So the robot can talk by the message that's been written by the operator. And Mavic-R also display the robot status, like battery voltage, connection status, camera switching, and speed control and etc. Those one is for the telepresence. this is the UI, the user interface. So if for those of you not familiar with user interface, this is basically the main dashboard or the main page that we can see on the controller. So imagine that you are inside the robots. That's the same thing as this. So if you can see on the left side, Alice, can you help to point out the yep, to the robot status?
Robot status on the left side.
On the left side.
On the left
side.
Yeah.
Yep.
Okay.
If you can see that there's a battery fault, and then there's a network connectivity. You can see also the speed, the acceleration time. Those are for the robot status. And also, if you connect with the UVC module or the disinfection spray, you can easily activate on those functions. On the second on the bottom of robot status, you can see the operator view. So it means that if you are using a webcam on the operator or in the control room, you can see the people that is controlling the robot. And then the third box, you can go down. Yeah. Those are the radar view. The radar view is basically show the reading of the safety sensor. It means that you can you are able to
check like
surrounding, sort of like that.
Yeah.
So it's like a radar in maybe like in
video games.
Video games like that. Thank you for the explanation. And then the last box on the left is the control pad. So the design of the control is we are trying to mimicking how the way PC gaming is done. So we're going to details later. And then on the right side there is a message box and the thermal camera. So you can see that the cursor is circling the thermal reading, and then you can see if you can click those. Actually, you cannot click, but if you can, if it's in real applications, and you can click the message box to put up some message there. Okay. So and this Mavic R is running on the what we call web apps. It's basically a web application. So it's not so. The systems are very flexible, and then the reason why is what we're going to show you in the next page. Please, 1 point. Sorry. Okay, the fourth function is the UV disinfection. I believe you already know that one of the most popular disinfection method, the so-called disinfection method, is the UVC light disinfection. So TOR-I comes with the UVC disinfection module that can be equipped alongside the robot or be used independently or detachable. So it means that if you are going to use in a place that the robot cannot go in, then you can transport or move the UVC inside the room manually, because they have this DC voltage and AC voltage. So DC voltage means that it's running on battery, so it can be mobile, go along with the robot. And if you are using the AC for the static use, it can be used in an inside room, and you can just simply plug the cable on the basic 220 volt outlet. The UVC controlled using the mobile applications through the Bluetooth connection. Through the Wi-Fi connection. Let me get let us correct later.
Okay.
And by doing this is that we put the safety factor on the first layer of what we implement. So on the mobile apps, you can calculate how long the periods of the radiation exposure of the UVC based on the pre-calculation that we have done in the apps. So let's say if you're going to radiate the UVC light on an area maybe like 3 × 3 meters square. So it will automatically predefine the periods of the exposure. And then once you already set up, and then you can simply send the instruction through your mobile apps, and then let the UVC operator present the command. And then later on, when the UVC is already done with the job, and it will give back the status. It will tell your mobile apps, as long as you within the Wi-Fi connections, and the system can say, okay, I'm already done with the disinfection job. You can move the UVC module from maybe to the next room or whatever. So those the setting mode and the operating mode. So one of the main reason that the safety is one of the big issue in implementing this, because the UVC disinfection is already known as maybe harmful to dangerous to human. So that's why we have two layers of safety there. The first one is that we are using the mobile apps. It is basically because you can do it remotely without having you in presence with the UVC in the same room. And then the second thing is that we equip the UVC using the motion sensor to prevent any harm. Let's say the UVC is already operating inside the room, and someone accidentally entered the room without knowing that the UVC is radiating the light. The system will immediately read the motion, read the movements of the person inside the room, and automatically turn off the lights. So motion sensor detect the sudden movement, such as person entering the room, and automatically switch off. And wait for several seconds to determine any possible person inside the room. This is what we try to design is the safety factor of the UVC disinfection. Okay. Yep. Can you help to put the video on play, Karisma? As you can see, you can left the UVC inside the room, and then you open the mobile apps and you turn on. As simple as it is. Okay. Okay, you can see that the UVC is operating through the Wi-Fi connections from the mobile apps. It is no matter you are using Android or iOS platform. It is basically a web service. It doesn't need to know about the OS of your smartphone. So basically, it's flexible enough to you. Okay. Let's continue to the next phase, the goods transporting. Okay, the goods transporting is very straightforward. So the robot can carry up to 4 stacks of tray with the maximum load to 60 kg. So as you can see on the right side of the presentation, you can see the the flow chart. The medical staff prepare the goods, staff operating the TOR-I, arrive on the destination. The medics are the interface to communicate with patients, checking status such as temperature, and ready for the next missions or the next order. We're not going through this a lot because it's very common. And then this is also the same like the UVC disinfection. We are using the different method. We are using the chemical substances. And this is the same principle that we use in the UVC disinfection, just a different way to do it. Okay, so the third sections of the TOR-I is the operating, how to operate TOR-I. So we call it operating TOR-I. So before I explain you to how to operate the robot, I think it's better to know that the reason why we are using manually operated is because that the first thing that we're going to implement in the hospital in Indonesia. There's a lot, as you know that maybe the robot is quite new technology in Indonesia, especially in the medical sections business, and there isn't a lot of hospital that make how to say, let me put this, robotic friendly.
Yeah.
Yes, because you know that there is a certain limitations of robot. Obviously, it's not as agile or as flexible as the robot. Maybe some of the robot you see on the website, like Boston Dynamics and everything, is very agile and very flexible, but those robot is still in the development. It's not in a production phase. It means that it's not really ready to be deployed in the real situations. That's why you see that all across the world, that the mobile robot is basically like a small car that moves automatically or maybe controlled by the human operator. So that's the strong point why we are choosing the manual control. Even though we put some function to help the operator to, how to say, you don't have to be experienced to control the robot, because the system itself have a smart assistant to help you to guide the robot. It's more or less like we are operating the drone, especially like from DJI. They already have like these smart assistants to help you to prevent any accidents. So let's talk about operating TOR-I again. So how the system works? So basically, you only need the controller, which is your laptop or tablet, and established connections. It means that you have this network internet connection inside the rooms, and then you have the TOR-I, obviously. So if you have these three, if you have these three functions, so sure you are able to move the robot without any problems. But if, let's say, if the connection is weak, or maybe if there is no established network inside the hospital, or maybe inside the factory, you can still control the robot, but obviously in certain range of connections. You cannot go very far without any established network. Okay. So this is the second page of this section is that whether you can use the PC or laptop or tablet to control the robot. So the staff can choose which device that suits them most depending on scenario of deployment. You can use the standard PC base. You are using the monitor, as I said before, that this controlling the TOR-I robot is almost the same like you are playing Counter-Strike.
Yeah.
Okay. If you are I don't know if you're not familiar with PC gaming, but I think the most flexible way is to implement the PC gaming based control to, how to say, to mimic the process in playing the game. So you have the PC and the mouse, and also another option is that using the laptop and joystick. This might be more natural if you having a background in
video gaming.
In video gaming as well, or if you have a background as a pilot, I don't know. And then the last one is the tablet and combined with the VR camera, because the camera that we are using is 360 view. So basically, it's very suitable to use as a VR virtual reality applications. For those of you if that not familiar with the VR, it's basically you put the
VR glasses.
The VR glasses like the Google Glass or the Oculus Rift, and then you sort of like looking through the robot eyes.
Yeah.
Looking through the robot eyes. That's the flexibility of the system, because we are implementing as a web services. That it means that you don't need to worry about the OS of the system. Maybe most of you guys using the Windows OS, obviously is very applicable using the Windows, and if you guys using Linux is not problem as well. But I'm not sure that a lot of people using Linux in the public places like hospital or like hotel or something. Those are the things, how the system work operating using the PC, laptop, or the tablet. I said yes. Continue to this one. This is the UI that we have seen before on the next and on the previous page. And then this is how the robot works. You can see that this view is a little bit googly, a little bit weird enough for you, but actually you can stretch out the image. I'm not able to do it right now because this is only the video, but in the real UI, you can actually stretch the image. So basically you turn the 3D images into the 2D or from 2D to 3D images. The reason why we are implementing this function is to give you a sense of presence of the robot, because you're operating this from far away. I mean, from remotely places. It's from our research background. It might be suitable that we have used this 360 camera to help operator to know the presence. It's more or less the same like if you see a lot of action movie like American Hollywood movie that you see the drone pilot using it. It's almost the same. Each drone robot have this dome camera. Actually, it's basically a 360 pound tilt zoom camera, so you can see the whole environment from far away. And you can basically using the Karisma, you can point out the WS, the keypad.
Keyboard, yeah.
Yes. If the reason is why we implement this, as I said before, is mimicking the process of PC gaming. So the WASD is the standard gaming keypad.
Yeah.
So we want to give you like sort of like a gaming experience, to when you control the robot, and then you can also using your mouse to change the perspective of the camera. Let's say if you want to see the back of your camera, you can just circle the rotate the image using your mouse, and then the rest of it is the same like PC game. How you do the gaming in PC. And interesting part is that I already mentioned that this system is using a semi-auto manual interventions, and then this is how the system works. The system is basically helping you to navigate the robot. So you are not really controlling by your own, but basically the system helps you to avoid any accident. So back again, safety is our the first layer of our development. So we think that using this semi-auto intervention control is to help operator when controlling the robot using the TOR-I depth sensor to reroute. Let's say if you have maybe like card or boxes or something that's static just left on the hallway, and you can just move. You cannot just move the object. The robot will help you to the system will help you to navigate the robot to avoid collisions. And also, if there is no way, if there is no way to proceed any further, then the system will stop the robot and give the warning that there is obstruction on the path and you cannot continue to the goal. So this is, I think this system is very unique with our system. I think in the same class of the robot, we haven't seen any types of this intervention control. Hopefully, it can give you an inspiration to people that been develop the system. It might be suitable to this teleoperated robot as a basic function using the semi-auto intervention control. So this, to put it simple, is that the robot is, yes, you manually operated the robot, but the system help you to easily navigate and avoid accidents. Okay, can you play? Yep. This is how to operate the robot. As you can see that. Can you just pause? Go back again.
Go back to Rahman.
Okay,
right.
pause. Okay.
Rahman over there.
And then there is our lead software engineer, very young, 21 years old, and he is controlling the robot as in gaming. Right, Hanif? Yes. So as Hanif said before, that this is sort of like avatar.
Yeah.
You bring your presence inside the robot and helping you to navigate the system. Please continue to the next video. Okay, stop. As you can see, you can see on the screen that the Mavic R logo. It means that the Mavic R software is running on the system. Continue. And then this robot stop demonstrating how the telepresence system works. So you can see that there's a face of people inside the screen on the robot, and then it basically communicate with the people using the white suit that maybe like
Yeah.
gears or something. Okay, by doing this, we can help a lot of. Maybe we can maybe in hospital scenario, we can help those medical staff to reduce the fatigue or of coming back and forth inside the room and the station using the robot, and also prevent any disease spreading, because we are using the robot. Obviously, that we can clean up the robot, whether you can use the UVC disinfections or not. So the software is pretty much straightforward. You can talk in two-way communication. If you can see, there's a white box on the right side of on the screen. Yes, those one are the COM box, the communication box. I'm not sure you can see that or not, but actually those are the communication box that the people in the operating group can give you the instructions. As the very easy one, as you can see, this is one of our office, and we have a very small, areas, and that's why the semi-auto intervention control come in handy,
Right.
helping the robot navigate. Because obviously in hospital, especially in Indonesia, pretty much the same. The condition is like this.
You don't have really much space inside a hospital.
Exactly, honey. Okay. Let's go to the next. Okay. Okay. In control. So the last one is for the battery and disinfecting. So the system can detect the low battery status as in your smartphone or maybe like mobile devices, and then give you the warning. You have to charge the battery. That's the first. And you can also have the charge reminder. Let's say if you use the robot in a routine way, it means that you can set up the reminder to, let's say, every 5 hours you have to charge, or maybe like every one shift, or maybe like 8 hours you have to charge, and so on. And it came up with a portable charging station. This is a very simple technology that might be coming handy for this mobile robot. And the last one is to disinfect the robot itself, because the robot is coming back and forth to the how to say, like the infected area. It means that the robot also needs to be clean. But instead of using the disinfectant chemical, you can use the more powerful UVC disinfection.
Yeah.
Yes, UVC light. Okay, on the right side, you can see that on the back side of the robot, you have this socket, electrical socket. It's almost the same like the electrical socket in electric vehicle. So basically, you just plug in the charger and then let the battery recharge for quite times. Okay, and alongside with the charging station, you can also do the disinfections. As I said before, that this disinfection can be used as mobile and also standalone. It means that if we detach the UVC disinfection and then we simply plug in the AC cable and let the light disinfect the robot. So basically, it's almost like self-healing. After you do the job in the wall, you can use this UVC disinfection to self-healing the robot, to make sure that the robot is not going to be the factor of spreading the disease. Okay. Okay, this is how we charge. It's basically we took the inspirations of racing car paddock or maybe like motorcycle paddock. So this is where they charge the portable docking station, and then the robot will come to these certain positions. To this docking station is not only for charging or maybe for the UVC, but also to move the whatever module that you want to install on top of the robot. So can you go back to where the okay, skip it to the
last part.
The last part when they charge.
Yeah.
Oh, okay. So basically, just plug in the cable like you do in electric vehicle. I don't know if you are very familiar in electric vehicle, but I think people from like China, Korea, Singapore, maybe like Philippines, Thailand already have this technology very common in their transportations. Okay, that's how easy the system is. So you can just plug in the cable and then let the robot rest. Or you can also changing the battery if you are having two sets of battery. That might be a good idea to have a second battery as a spare. And the next and the last sections of the presentation is the developments of TOR-I. So you might be wondering that why there is no auto functions, the auto functions of the robot, or maybe like the autonomous control of the robot. Please keep calm that we are already working on it. And then I think by deploying this mobile robot is going to be how to say to be the next standard in the byproduct of the pandemic, COVID-19 pandemic. Mobile robot is one of the standard that will be deployed in like such in medical facilities, like in a factory, on hotel, and something. So that's why automating the process is certainly a very good idea. So in the next development for the autonomous versions, we'll be having two autonomous navigations. The first one, we are using the VSLAM. For those of you not very familiar with SLAM, SLAM is basically an algorithm, a combination of algorithm and hardware design that, let me put this way, if you know how the sailor navigate the ship on the sea, it is basically combining the how to say not sea.
The compass.
The compass, yeah, the compass, and you can use the sky as your guidance. The same principle as VSLAM is that we're combining both inertial control and also the camera to help the robot navigate automatically. The same like again like Tesla. The same again like what we see in autonomous car, maybe like Tesla or maybe like Nissan. They also have this technology. And obviously, one of the biggest challenges in a VSLAM it needs to be taught. The robots need to be, how to say, need to be introduced with the environment.
Yeah. It needs to learn. It needs to learn about the environment first.
The very basic, I'm not saying mistake, but misconceptions of the robot is that basically this robot is very smart. And then you put this robot to anywhere and let's have some action. And basically it's not very impossible, but currently those technology is not ready yet. Yeah. So basically, if we're talking about the fully autonomous VSLAM, fully autonomous robot that can be navigated all through the room, it can be done. But please keep in mind that this robot is not as smart as people. It means it needs to be taught. That's why the manually operated came first, and then later on, when we have this autonomous function ready, that we can then the scenario would be like this. First, you manually operated from the remote area. You put the robot inside the remote area, and then while you operating the robot, you can also teach the robot to learn about the environment. And then later on, once you've done the training, and then you can go with the fully autonomous. And then the most popular, the second one is very popular in manufacturing. It's basically a line tracking devices. I think some of you guys in the robot sector, maybe like from academics, might think that this technology is very old.
Yeah.
But turns out there's this technology, aside from very old technology, but this one is very stable. So that's why in manufacturing factory, there's a lot of magnetic taps robotic because it's not just simple, but very reliable.
Yeah.
But we do some tweak here because we're not using the magnetic tap inside the hospital, but instead of using the magnetic, we are using the the blower tap.
Mm-hmm.
You can see there's a lot of I think in ICU or in HCU, there's a lot of floor. You can implement the floor tap, and then you can teach the robot to navigate using the camera to detect the line. And then once you have these fully autonomous functions, you can combine with auto scheduling modes. As auto scheduling mode, for those of you not familiar, is a very standard procedure in mobile robotics in industry. So you can you use this auto scheduling mode to automatically send the instructions to the robot. Okay, you have a minute?
Oh no, we can.
Okay, so this auto scheduling mode is fitted perfectly what if the autonomous version is ready. So this is the next developments of the functions. I'm not sure it's very common in maybe like medical facility like hospital, but it is very common in industrial nowadays. So it's this is what we call in factory that we call MRP. Material requisition planning. So basically a whole system that orchestrate the whole process. So from you gather a lot of data. Let's say if you put in industrial perspective, it means that let's say in a car manufacturing, you have this type A, B, C, D, and so on, and then the system will automatically pick which one to produce based on the customer requirement, and then once the system is deciding which one is going to be produced, and then the material will be sorted out, and then the robot will have this material delivered to the assembly room. The same principle that we would like to implement here. This is what we call the medical strategy control. I'm not sure whether the term is good or not, but basically we are combining the TOR-I robot and the Mavic R software embedded on the robot with what we call the robotic process automation, or RPA, for fully integrated system. So this is just a scenario that might be in the future. It might be good as a new standard for medical facility. As you can see that this robot can help you to monitor all the patients inside the ICU and HCU room. But by doing so, that the robot is not directly contact the human. But if I'm not mistaken, please correct me if I have one statement there. But if I'm not mistaken, in ICU you have this ICU and HCU, you have these monitors. You see to see the vital signs, maybe like the oxygen level, or maybe like the ECG and everything. Then we can implement the robot to monitor these vital signs, and using the camera to detect to detect and observe the readings of the monitor, and then get these vital signs into the central into the control room to have the doctors or maybe nurses to analyze the data. But by doing this, we can help to ease the fatigue of the people, and we can also see the trend of the patient itself. Let's say like you can compare with the vital signs, daily observation, and maybe like a medical record in one process, and you can also have this system through the smartphone. Let's say if the doctor is not present in the room, the doctors can actively see the progress of the patient, whether it increase or decrease the status. And then by implementing the RPA, the stock robots, it can be using the auto record to collect all the data. And then if we're talking about the next feature, because the so-called 4.0 revolutions, it means that it's not only happen for the industry like manufacturing, but it may be also happen to like public places, like maybe like hospital. By gathering the data, you can perform data collection analysis in the next future. Let's say if we are done with this pandemic, that may be a next pandemic later on. The system. We hope that the system we can are able to help and maybe like becoming a new standard for to helping and to prevent the COVID-19 disease. So I think this is the last pages that I'm presenting you, but I would like to address some things that before I close the presentations, that maybe some of you guys is coming from the medical background. Maybe some of you guys are coming from the industrial background. And maybe some of you guys are from academics background. As I can say, this robot was designed to help intentionally to help the medical staff to prevent to battling COVID-19. So that's why medical staff or nurses, doctors, medical scientists know better of the applications, know better about the application. And also maybe from the academics point of view, usually the academics in like university, they have the advancement of technology. Usually they already maybe 1 or 2 steps ahead from the industry itself. And then as our from perspective, from our perspective from industry, we would like to glue all those things together. So the advancement of the academics and the needs of the medical staff and the medical researcher or medical doctors, and we glue it all the needs together, and then looking forward to the next to a real and how to say accessible solutions to all of us to battling this pandemic. Okay, I think that's it. Thank you for joining us and looking forward for your feedback. As I said, as the global news said that get ready for the new normal, maybe this technology can help to get along with the new normal. Thank you, Hanif.
Yeah, thank you very much, Haikal, for sharing today. Yeah, that was a lot of information for one presentation, but do not worry. We will share with you the presentation after the webinar ends. So we will make some minor changes to the overall presentation. Maybe we could fix a little bit words here and there, but we will share to you so you can access it and you can learn it by yourselves. So after this, we will have a short, brief demonstration right from our Aero Lab, which is our Artificial Intelligence and Robotics Lab. So I'll send it over to Raditya and Fuad over by the workshop. Please present to us the demonstration for TOR-I.
Okay, hello. Can you hear me?
Yeah, we can hear you very clearly.
Okay, good. Okay, so thank you for the presentation. So we will continue to the live demo. So at the first, I will explain about the parts, just a common part. So the first one, this is a 360 camera here at the top side. Then there is a antenna. If you can see, the antenna is for the routers to broadcast the Wi-Fi connection to the other side. So the next is a webcam. So webcam is, as you know, is for telecommunication between two sides. The next thing is a monitor, as you can see here. The next is a lamp. We have 2 lamps because we have a surveillance mode also. So the robot also can walk in the dark area. So we can turn on or turn off this lamp to, yeah, depend on the situation. The next thing is a thermal camera here. So the robot also can show the thermal camera. It's whenever people around here. So it will also show in the other side. The next thing is a speaker. Speaker is as you know, the speaker produces the sound to the other side also. Here is an emergency button. If you press, if for any emergency situation, you just press this. Next thing is a power switch, the normal one. The next thing is a socket. Here is socket to the any module. We have 6-in-1, right? Each module you just plug here and then the plug to the other modules. So it's very efficient. As you can see, it's a LED to indicate the on or off the robots. And here also is an obstacle sensor. So the robot will not bump to any a wall or something or people around. So it's very safety. If you move to back side, there is also LED and the obstacle sensor. And then here is a charging point, just like a Tesla. If you know the Tesla car, I bet you all know. So you just plug here with a dock. We have a dock. Adit, maybe? Adit? So Mr. Adit will show you how to charge first. So we have a very light dock, charging dock. You just put there, and then plug into the any power source. See, the light is on here. So Adi will plug into the robots there. Yes. So there is indicator here. So it means charge is on process. And also here red. Red it means below 90%. So the battery in the robots is still, the voltage is under 80%. The function of dock also have like bridge to put in the module on the robots. So we can do like this. So the module can be put on the robots while AGV is charged. Kembali. Oh, the pochette, yeah. Naik. So this is the appearance when the AGV with rack. It means a module, rack module. So rack module consists of many cabinet to put something you want to deliver to the another area. Okay. So if done, you can unplug the ini, bawa pergi aja. So after that, you can take out all the dock and you can put another. So the next thing is AGV movement. So as Mr. Haikal said in the previous presentation, so we just use WESD. As you can see, W is for forward, move forward. D is for turn right. So we can also increase the speed. Yeah, the robot is running. And I can also turn on the camera there. Yes, you see me on the screen. Hello. And also they have a chat box there, so I can type anything I want to share with the other side. It means the robot side. So I try to type hello everyone like this. It's so there, right? Kelihatan nggak? Okay. So the chat box is very useful. Let's say if you have a many list part, you can type like this, maybe. So for room 201A, please take blanket 20 piece, pillow 20 piece, etc. So the nurse or someone there can precise take the quantity of material in the rack. Chat box also can be useful for any example for medicine. Let's say they aspirin, 2 piece. Let's say aspirin 2 piece or etc. So the chat box is very useful. Okay. And also we can talk. We can talk with the other side. Maybe someone can be on the robot side. Hello? Can you hear me? Oh. Okay, so we can talk with Mr. Gaby here. Gaby is one of our engineers. Hello, Gaby. Can you hear me? Okay, I can hear you also. So, and also we, okay, Gab, pergi Gab. Udah, okay. Okay, thank you, Gaby. Thank you. And also we have light, yeah, as I explained before, we have a light. It's a ring light here. So we can turn in, turn off, turn on, turn off, guys. And also highlight, we call it highlight. It's very light. So it's used to, can be used in a very dark area. Okay, so we continue move with the robots, maybe. Okay, next I want to demonstrate you how to change to with another dock, another module. We try to with UVC module. So we take out the rack. But before that, I will explain you to the UI. So let me do it. As you, yeah, it's very easy to move, easy to control. Okay. Okay, next is I want to explain you about the UI. As in the Mr. Haikal presentation, so the first is here is a control. Is a, as you can see here, is a signal. It's a signal from this laptop to the robots. The second is a toggle for the sound. Is a on and off the sound. This is a camera for enable disable camera and the robot side. The next thing is for 360 camera here. As you can see, the robot move. I can drag and drop the location. I can drag and drop for the point of view. So you can see all of angle here. Can drag and drop. So there is no like bump something. Okay. The next thing is a battery voltage. So if the battery is a drop below below at let's say to 20%, so we have like alarm. We have alarm here to need to charge. The next thing is action. Action is depend on the what module. So what module to be attached. So we have a 6-in-1 module. So we will later on we will explain to you what the action button is. The next thing is a ring light. So as you can see before, the ring light is a switch to on or off the light. See, ring light on off. Okay. Okay, next thing is a speed. Speed also can be adjust from here. So we just slide left and right to have value. We have 0 to 255. We have a medium speed here, and then the acceleration time also. This is a camera. This is from my camera. This is it's a webcam from the laptops here. The next thing is a obstacle sensor. Here is obstacle sensor. So if AGV near something, there is increase the value here also. Okay. Oh. So the next thing is a AVHD. So yeah, the control. Okay. Okay, I think that's all from the workshop side and lab side. I will get back to Mr. Hanif.
All right. Thank you very much, Fuad, Raditya, and everyone from the Air Lab workshop. So after all of this, we have a Q&A session open for all of you. So questions are encouraged in English. But if you want to ask something in bahasa Indonesia, we'll answer it. Jadi buat teman-teman semua yang ada di sini, kalau misalkan ingin bertanya pakai bahasa Indonesia juga nggak apa-apa, pakai bahasa Inggris juga nggak apa-apa. Kita akan menjawab pertanyaannya dalam bahasa Indonesia dan bahasa Inggris. Jadi di sini udah banyak yang bertanya. So there have been a lot of you guys asking a few questions. Maybe we could answer a few of them first. And if you guys have any other questions that you would like to ask, we are very much open. We are very much open to answer all of your questions. So you can just click the Q&A button down below. You have the Q&A button, and you can put your questions into the Q&A box, and then we could choose your questions, and we can show your questions to all of the participants inside of the webinar. So let's start the Q&A session then. Which question? Yeah, we can start with any question. Yeah. First one? Yeah, the first one. So you can see that we're trying to answer the question from an anonymous attendee. His question or her question is, how many payload can be carried? So maybe Michael can answer that.
Yes, for the payload is for 60 kg. It means that the robot can lift up any medical goods or transporting goods up to 60 kg. And also it can lift up the module, especially for the UVC and the disinfection spray module. So it's maximum 60 kg for the operations.
Jadi untuk pertanyaan yang pertama, berapa payload atau berapa beban yang bisa diangkat sama TOR-I sendiri? Berat yang bisa diangkat sama TOR-I sendiri ini maksimal adalah 60 kg. So maybe next question, Haikal can answer in Indonesian. I can translate your answer into English. So let's go to the second question. So it's from Sri Wahyuni. For the spray decision, does it perform locally by the robot's embedded processor or remotely by the server? Untuk mendispektasi dengan cara spray, apakah dilakukan secara embedded processor yang ada di TOR-I atau remote menggunakan server atau web application? Mungkin Haikal can answer that?
Ya, untuk proses ini kita bisa melakukannya dalam dua hal. Jadi untuk mungkin Ibu ya, Ibu Sri Wahyuni ini for the spray decision, kita bisa melakukan dalam dua metode, yaitu pertama benar menggunakan local dari si robot embedded processor, dari remote juga bisa, dari server. Dan bisa juga di set auto nanti mungkin kalau misalnya ada trigger position.
Okay. So for that answer, you can use both the robot's embedded processor using the auto scheduling program, or you can do it remotely using your operator's hands and operator's controls. You can do the spray decision, or you can use the spray operation manually using the server or the web application. So I hope that answers your question. So the next question that we're going to answer is from Ms. Sheila. Can you explain more about the operating method? You said that it still needs operator to move TOR-I. How the operator can define the track, or is the robot using wire or laser for guide? Jadi pertanyaannya adalah, bisakah menjelaskan lebih lanjut mengenai metode operasi dari TOR-I? Disebut sebelumnya bahwa dibutuhkan operator untuk menjalankan TOR-I. Bagaimana caranya TOR-I sendiri mendefinisikan track? Apakah dia menggunakan kamera, menggunakan laser, atau bagaimana? Mungkin bisa dijawab oleh Haikal dulu.
Ya, jadi kalau untuk operasinya itu sendiri benar, itu menggunakan manual control ya. Jadi ada operator yang mengendalikan si robot itu. Jadi si operator yang mendesain pergi kemana dan segala macam. Cuman yang unik dari fungsinya si TOR-I ini adalah kita taruh beberapa sensor ya. Jadi tadi ada laser top sensor itu time of flight, sama nanti penggunaan dead camera itu untuk membantu meng-guide. Jadi kalau misalnya kita mau lurus nih, ternyata di situ nanti ada beberapa obstacle atau objek yang menghalangi. Si sistem itu akan mencoba untuk melakukan reroute gitu ya, misalnya belok kiri, misalnya alternatif nanti bisa otomatis belok kanan atau belok kiri, atau mungkin kalau misalnya nanti benar-benar tutup jalannya itu stop gitu Mas.
So to answer that question, this story, it uses a manual control just as like we presented before. But what's interesting about the manual control is we implemented a lot of like assisting features such as the standing auto drive control and all of those sensors that you can find, the time of flight sensors, the distance sensors that we put around the TOR-I. So it helps the operator determine their location when using TOR-I as a method to like transport objects or to practice telemedicine activities. So we put the operator's view, the operator's role as our core development idea. So hopefully by developing all of those sensors, all of those controls, we can help ease the operation, whether it's used by an expert or by a beginner, like most of people not familiar enough with robotics. So I hope that explains and that answers the question. So we can move to another question by Mr. Aldi Sugiarto. Can robot detect the patient information, and how to ensure that robot not be carried of virus? So, jadi untuk pertanyaan dari Pak Aldi Sugiarto, yang pertama adalah bisakah robot mendeteksi informasi yang dimiliki oleh pasien ya. Lalu yang kedua adalah bagaimana cara robot itu memastikan, bahwa robot sendirinya tidak membawa virus ke ruang-ruangan. Mungkin bisa dijawab oleh Haikal dulu.
Ya, jadi untuk pertanyaan pertama, can the robot detect the patient information? Untuk pada development phase ini yang bisa langsung diambil datanya live dari si pasien itu adalah suhu. Jadi suhu itu kita bisa real time gitu ya. Terus kita juga bisa menggunakan kamera itu juga untuk mendetek mungkin hasil-hasil pembacaan yang ada mungkin di monitor di rumah sakit dan macam itu untuk menjawab yang pertama. Tuh, jadi kita kalau yang benar-benar langsung ke si patient itu baru si temperatur. Tapi tidak menutup kemungkinan nanti kita bisa develop ke yang mungkin ke oxygen level dan segala macam, karena itu sebetulnya development yang cukup straightforward, sensornya juga udah banyak gitu ya. Jadi tinggal digabungin ke Matrix R, karena Matrix R ini kita sistemnya kan WebSocket ya. Jadi kita udah nyiapin beberapa modul untuk diintegrasiin gitu. Nah untuk
for the first question, it's interesting because as we presented before, we gave you a look on how hospital environment, how the hospital industry could literally change its score when facing COVID-19. So imagine that all of the patient's data, like oxygen level, all of his heartbeat readings, blood sugar level, etc., are now stored in a digital file or a digital data that later on can be streamed or can be extracted by TOR-I itself. So this is going to be one of our concerns in developing TOR-I for the future iterations, which means that when you save patient data, you can show the patient data of a specific patient on the TOR-I display itself. But whether as for now, we can only show the temperature detection level of the patient, or you can stream all of the digital data that you have inside of the electronic devices inside of the room into the TOR-I itself.
Ya, pertanyaan kedua gimana ya?
Pertanyaan kedua tadi yang Pak Aldi Sugiarto
gimana ya?
Bagaimana sih?
Oh ya, jadi how to ensure that the robot not to be carrier of any virus. So standar operasi dari si robot itu sendiri adalah yang tadi kita sempat jelaskan itu adalah portable docking station. Jadi portable docking station itu tidak hanya digunakan untuk charging, tapi kita juga gunakan peralatan itu untuk melakukan disinfeksi, self disinfection buat si robot. Jadi salah satu SOP-nya adalah pada saat robot itu masuk proses pengecasan, kita bisa kombinasikan dengan UVC modul tadi ya yang bisa dibawa-bawa si robot itu untuk dipasangkan di station, di portable station itu untuk melakukan disinfeksi langsung ke robot gitu. Karena si UVC modul ini kan kita desain untuk dua purposes ya, mobile sama static. Nah, nanti kita aktifkan yang mode static itu untuk bisa disambungkan ke plug AC untuk diinspeksi robotnya gitu.
So as you can see before, we have this charging station docking feature or accessory that we provide with the TOR-I. So this charging dock or charging station will be provided with one of the TOR-I's accessory, which is the UVC module. So for example, when the robot goes to charge their battery on the charging station itself will light the UVC LED tube lamps, and the UVC lamps will disinfect the TOR-I so that the TOR-I is free from the virus. But it's also worth to mention that this robot does not need to interact directly with the patient. So, for example, the patient does not need to touch, or the patient does not need to get too close to the robot for the robot to do its job. So it's important to keep in mind that physical distancing also works on robots. So they can also carry virus. So it's better for us to also keep distance with the robot. So I hope that answers your question. Semoga itu menjawab pertanyaannya. Berikutnya mungkin pertanyaan, a question from Mr. Takui Shikawa. Is there any device or tools to open or close the manual door? Apakah ada tools atau alat yang bisa digunakan untuk membuka atau menutup pintu yang sekarang biasanya kalau di rumah sakit manual gitu? Mungkin bisa dijawab.
Oke, untuk phase development ini secara by design kita belum ada di situ. Tapi kan itu sesuatu yang sangat common gitu, Mas Hanif di kita yang biasa kita di industri. Jadi kita lihat ke depannya itu akan di-develop juga. Untuk sekarang belum.
So we've had this inquiry for a while from our current customers. They want to automate their doors so that people don't need to touch or don't need to have a direct contact with their doors. We will keep in mind in future iterations and future developments. As of now, we want to dedicate the operational for the story on doors or situations that will be defined as traditional. So there will not be additional automation involved. There's no automatic doors. We thought of that during the development process so that the usage is more targeted to the traditional landscape or the traditional situation. But as we know, because COVID is transforming everybody from a digital perspective, from a technology perspective, we may see a development or an upgrade from all of these hospitals, factories, etc., to automate the doors. And I could say from a marketing perspective that we could do that for you. Let's see what we can develop so we can help you. I hope that answers your question. Semoga itu menjawab pertanyaannya. Maybe we could move to another question. Can the operator choose a question, please? Many hospital. Oh, okay. Maybe from Mr. Deswibowo. Many hospital and building have more than one floor. Can robot move to the other floor using lifts? Banyak rumah sakit ya atau gedung-gedung yang mungkin lantainya lebih dari satu. Bagaimana cara robot ini, si TOR-I, dapat bergerak untuk pindah dari lantai satu ke lantai lainnya? Mungkin dimulai dari Haikal dulu.
Ya, terima kasih Anik. Jadi kalau menjawab pertanyaan Pak Desibo ya, Pak Desibo, many hospital building have more than one floor, 3 floor, for example. Aplikasi mobile robot di industri itu untuk satu lantai, 2 lantai, 3 lantai itu udah cukup common gitu. Jadi untuk TOR itu sendiri tidak mengalami kesulitan untuk bisa diimplementasikan jika harus bergerak dari lantai 1 ke lantai 2 dan lantai 3. Nanti memang betul dibutuhkan development untuk integrasi ke sistem liftnya, tapi itu sudah sesuatu yang cukup common, jadi tidak sesuatu yang possible, tidak impossible.
Okay, so we've had this experience in developing robotics or AGVs that moves from floor to floor. So for us to develop that kind of application for that specific situation, it is possible. We need to develop the communication protocols between the lifts that are used within the buildings, the hospital buildings or factory buildings, with the communication protocols of the TOR-I itself. But this type of application is very much common. Like you can find it in like 2 stories, 3 stories factories or at customers that we've served before. So I believe that it's only a matter of like choosing the right communication protocols and the right way to communicate between the lifts and the AGV. So mungkin itu bisa menjawab pertanyaannya. Terima kasih banyak sudah bertanya. Berikutnya, the next question maybe we can answer from Mr. Moon Sung-chol. Mr. Moon Sung-chol joining us from South Korea. His question is, have you applied TOR-I to any of local hospital or staff places? Apakah TOR-I ini sudah diimplementasikan di rumah sakit atau di lokasi-lokasi lain yang sesuai, gitu, yang serupa?
Ya, untuk menjawab pertanyaan Mr. Moon Sung-chol, have you applied TOR-I to any local hospital? Currently in this space, not yet. Jadi belum. Jadi kita sangat eager ya, sangat open gitu ya untuk misalnya ada mungkin dari rumah sakit atau mungkin dari institusi pendidikan, mungkin dari university yang bisa bekerja sama dengan kita untuk kita implementasi bareng-bareng si robot ini, gitu sih.
Okay, so quick answer is not yet. We are very open. We're very much open to the notion of collaborating with academics, with hospitals, with universities, with anyone who would like to implement this robot at their space or at their site. We are very much open to inquiries. So if you know somebody that would benefit, or if you know someone who would like to use this type of technology at their site, at their buildings, etc., please do not hesitate to contact us directly. We will set up all the needs, the basic needs, all the protocols needed to implement this at your factory, hospital, or public space area. So please do that. And we hope that after this webinar, we can have a lot of more interactions with hospitals, with public spaces, with aircraft carriers, with train stations, every public areas. We can help disinfect. We can help with the use of TOR-I. Please do reach us directly to our contact person within the catalog that we have shared to you. So I think I hope that answers your question. So maybe we can answer another question from Mr. Bowie. I think that's an interesting question. What is the distance determined between the control operator and the robot? Bagaimana jarak yang mesti dijaga atau berapa jauh jarak antara operator dan robot yang bisa dilakukan? Mungkin seperti itu kali ya pertanyaannya. Mungkin itu bisa jawab?
Ya, jadi dari sistem komunikasi robot itu sendiri, selama ada internet connection, gitu ya, jadi selama ada established network itu mostly nggak ada masalah sih, jadi akan tetap connect sih, Jadi mungkin menjawab cukup yang menjawab pertanyaan.
So basically, the most important thing before you talk about the range between the robot and the operator to control the robot is you have the sufficient available Wi-Fi or internet connection to support the controls or to support the communication between the operator and the robot. So it doesn't matter how far or how long the distance between the station of control to the TOR-I. What matters is whether you have a stable enough internet or a stable enough connection between the robot and the charging station. Maybe you would like to use like LoRaWANs, long-range wireless access networks. Maybe you would like to use like local area networks. Everything can be done, but you need to be aware about the connection and the stability of safe connection, so it could support the communication between TOR-I and the operator. So semoga itu bisa menjawab pertanyaan dari Pak Bowie ya. I hope that answers your question. So is there any other questions that we could answer? Maybe we could answer the which one? Which one? Okay. We have another question from Mr. Taku Ishikawa. How do you suggest to utilize TOR-I after this pandemic settle? Can TOR-I be upgraded into autonomous only software update or require hardware modification? Bagaimana caranya? Apakah sugesti kalian dalam mengutilisasi atau menggunakan TOR-I ini setelah pandemi ini selesai? Jadi maksudnya adalah ketika sudah selesai pandemi ini sendiri, apa mungkin cara penggunaan atau aplikasi yang cocok untuk menggunakan TOR-I ini? Apakah TOR-I ini harus di-upgrade secara software agar menjadi fully autonomous, atau mungkin dia butuh hardware modifikasi untuk bisa menjadi autonomous AGV? Gitu. Mungkin dari Haikal bisa menjawab pertanyaannya.
Ya, terima kasih si Kausan. Jadi, how do you suggest to utilize TOR-I after the pandemic settle and the upgrade to autonomous? Yes. Obviously kita mengarah ke situ, jadi ini akan bisa dapat di setup autonomous gitu ya, jadi setup autonomous dan tidak perlu menambahkan sensor lain karena nanti kita akan manfaatkan sensor yang sudah ada. Jadi yang perlu diupdate itu nanti software patch-nya.
Okay. Untuk hardware?
Enggak.
Okay. So to answer Mr. Ishikawa's question. This robot can be used to basically this robot is used for manual and also can be used as a autonomous AGV. It's only a matter of developing a software that can fulfill the needs of using autonomous algorithms and autonomous control methods to help the robot itself plan the specific area or plan the specific routes that it needs to go through. So it doesn't need any more hardware modifications. All the parts and all the sensors that is equipped with the TOR-I will suffice and could support autonomous only applications. So I hope that answers your question. Maybe we could answer some more questions. So if you guys have any more questions, please do put down the questions on the questions feature, or you can answer us, or you can question us via YouTube. So another question is from Mr. Tino Wen. He is participating from the YouTube link, from the YouTube live stream. So Mr. Tinoan asked, any certificates for medical or hospital usage? If yes, what is the certificate? So pertanyaan dari Pak Tinoan, apakah ada sertifikat untuk TOR-I sendiri digunakan di rumah sakit atau di kondisi medis? Kalau misalkan ada, sertifikasi apa? Kalau misalkan tidak ada, mungkin sertifikasi apa yang bisa ditempuh ya untuk memastikan bisa digunakan di latar medis atau latar rumah sakit? Gitu. Mungkin bisa dijawab.
Untuk sekarang kita belum punya ya untuk sertifikat itu, jadi kita sangat open nih, kita sangat eager untuk collab sama mungkin rumah sakit ya untuk kita pengen tahu feedbacknya mereka dan apa aja sih yang what is need to be done to have those kind of certificates.
Okay, so
and actually for disclaimer, this is not medical equipment. I can say.
Yeah. Okay. So that's an interesting question. First of all, we would like to note that this is not what you call a medical device. What you call a medical device would mean that you're saying that this equates or this is the same as like a ventilator or like a diabetes blood measure, etc. This is not a medical equipment. This is a industrial equipment used to support medical purposes. So if you can see the thread or you can see the connection between those two words that I mentioned, it is not in the same area. You can't equate this device as a medical device, but this device is more of to help other medical devices. So for a quick example, you can imagine that you have a lot of like medical devices like ventilators, blood pressure counter. On the patient ICU room, you can use this robot to stream the data from those types of medical applications or medical devices to this robot. So to circle back, this device does not have a medical certification, but this device is only used for supporting medical applications. So I hope that answers your question. There's another question from the Zoom participant from I think Shelia Ginarco. Can you explain the mechanism of emergency operations for TOR-I? Is there something wrong? If there's something wrong with the system and there's human error, can it be as it's still operated by human? Jadi pertanyaannya dari Bu Shelia ya, apakah bisa jelaskan mekanisme emergency ketika robot ini digunakan dan terjadi suatu malfungsi atau terjadi error ya? Nah mungkin bisa dijelaskan sama Pak Haikal dulu.
Ya. Oh ya, oke. Kita juga sudah implement atau embed beberapa warning sign gitu ya. Jadi warning command di dalam si prosesor gitu ya. Jika errornya itu datang dari dalam. Itu yang pertama. Terus yang kedua, jika itu ya warning mungkin kalau tadi kita sempat bahas di yang semi auto intervention control itu dari software, dari sensor itu kan dia akan bantu untuk identifikasi ya. Ada sekitar misalnya nanti ada objek yang mungkin berpotensi untuk ditabrak dan segala macam, itu juga akan diberikan warning gitu di dalam interface-nya gitu.
So to answer that question, we have embedded a few warnings.
So to adding up, I think the last line is if there's an human error. So basically the intervention software, intervention control is to minimize the error in to minimize the human error.
Okay, so what we developed is we embedded a lot of like warning systems or warning protocols for the operator. For instance, to notify whether the battery is low or whether a specific space isn't explorable for the AGV. But at a basic level, we developed all of these features just to minimize the errors that could happen if you use it autonomously. So we kind of see it as a much less riskier method of operation than using a autonomous robot. So I hope that answers your question. We would like to disclaimer again that to use this, we suggest using manual operations because it is much more reliable than using like autonomous or fee-slide methods. So I guess that's it. Ada pertanyaan lagi dari anonymous attendee. There's another question from an anonymous attendee. Apakah yang membedakan dengan robot Raisa ITS? What is the main difference between TOR-I and the robot that ITS made? So to fill up the info, ITS is a university from the Java island that also produces and designs a similar robot as TOR-I. So maybe Haikal himself is from ITS. Maybe he has more information, or he has like insider information about that matter. So
Okay.
Haikal, maybe you can answer that question.
This is a very interesting question there. Jadi, what is the difference between the Raisa robot from ITS and with us? Apa yang membedakan dengan robot Raisa ITS? Mungkin yang perlu diketahui adalah dari perspektif developmentnya dulu sih. Mungkin kalau dari TOR-I ini karena dia datang didasarkan dari desain industrial mobile robot, ya. Terus yang kedua juga beberapa platform atau function yang ada di robot TOR-I ini mungkin bisa dibilang lebih bervariatif gitu ya, karena mungkin berdasarkan pengetahuan saya yang saya tahu tentang robot Raisa ini, tapi mungkin nanti bisa dikoreksi jika ada yang keliru. Itu Raisa punya beberapa teknologi yang cukup advance gitu ya. Kalau nggak salah dia ada yang untuk heartbeat, untuk deteksi heartbeat dan segala macam. Nah, makanya dari situ kita juga sangat open gitu untuk bisa berkolaborasi dengan institut edukasi gitu, seperti ITS, karena kita tahu sendiri ITS ini salah satu mungkin bisa dibilang jagoan robot lah ya di Indonesia, one of the biggest major university. Jadi it will be a great idea, ide yang sangat baik jika kita bisa mungkin mengkawinkan teknologi TOR-I dan Raisa.
Yeah, that's an interesting answer. So we all know that COVID-19 is a global issue, not just a personal issue for us or for some of us. So we hope that we're not here for competition, or we're not here for to fight each other, but we want to work together with everyone that is involved today or involved later in the future. So circling back to the question, what's the main difference between this robot and the robot that was developed by ITS? We acknowledge that ITS themselves are a big player in the robotic industry, or the robotic marketplace. So we hope that whatever that we develop here, we can also work together with them, so that or anyone else in that matter. But surely anyone else, we haven't yet received any a materialized cooperation. So we hope that we can materialize a official cooperation together, so we can answer the question on how to fight COVID-19 together with technology. So I think that will answer the question. We do have a few more questions from Mr. Mans Singh Shaw. have you acquired any certificates such as CE, FDA, or anything? Apakah kita sudah menerima sertifikasi CE, FDA, dan sebagainya?
Not, but we are working on it.
Again, this is not.
Again, for the FDA, this is not a medical device.
Okay. So to answer that question, again, like the same as Mr. Tinowen's question, this isn't a medical device, so we're not aiming for that type of certification. We're hoping that a lot of people define robots as not as a medical device, but as a supporting device for medical activities. These types of medical activities is not particularly specific to activities like blood test taking, etc. And we're hoping that it is more to assist operational workers or hospital workers in doing their manual or reputable activities. So I hope that answers your question. So another question is from Mr. Lee Hui Chong from Vietnam. I saw the video on the charging method is manual. The system can be automatically charging. Jadi pertanyaan dari Mr. Lee Hui Chong, apakah sistem chargingnya bisa diubah dari manual menjadi otomatis? Mungkin bisa dijawab?
Ya, untuk yang tipe TOR-I sekarang itu tentunya ini masih manual gitu. Jadi kalau untuk automatic charging berarti kita juga harus ganti mode si robot itu jadi autonomous juga seperti itu. Tapi kedepannya nanti setelah kita develop autonomous berbarengan dengan develop auto charging.
Yeah, so basically to answer your question, yes, it can be changed to autonomous charging, but we need to also change the TOR-I into an autonomous robot also. So it's two birds of a feather. We will develop it on a future iteration. For now, we're focusing on manual charging and also manual operation, but we will see whether if manual operations and manual charging is successful inside of hospitals, then maybe we could study more about autonomous navigation for hospitals and also autonomous charging for the AGV. So I hope that answers your question. There's a few more questions before we finish. Do you want to answer?
Yeah,
okay. So we can answer those two questions because it comes from one person, Mr. Sri Wahyuni. Question is, for navigating the robot, do you combine the input from camera and optical sensor?
Yes, we combine.
Jadi pertanyaannya adalah untuk navigasi robot, apakah digabungkan input kamera dengan optical sensor? Jawabannya iya, kita menggabungkan. To answer your question, yes, we combine both the camera and the optical sensor into one navigation mode. Thank you for giving that question to us. Your next question is, what is the current processor for TOR-I? And for TOR-I autonomous version, what is the processor you plan to embed? Maybe Haikal can answer that question.
Yeah, basically, now our processor now is industrial processing that capable to perform any like an artificial intelligence applications. So that's it's a very high processing unit. And then to answer the second question for the autonomous version, what is the processor you plan to embed? It is the same processor that we are using in the manual.
Okay, so to answer that question, first of all, the current processor uses an industrial grade processor that can be utilized to do AI applications, IoT specific, or other technologically advanced applications. And in the future, we will not change the industrial grade processor unless there's some adjustments that we need to make if the future is different from the present. So Untuk menjawab pertanyaannya, prosesor yang sekarang menggunakan prosesor standar industri yang biasa kita gunakan untuk memproses dataset artificial intelligence, menjalankan software AI, menjalankan software yang secara ekstensif itu membutuhkan power yang gede, dan kedepannya kita tidak akan mengubah hal itu kecuali ada kasus-kasus spesifik yang harus kita menyesuaikan dengan teknologi kita sesuai dengan kebutuhan yang ada di lapangan. Mungkin itu bisa menjawab pertanyaannya. Maybe that answers the question. I think that's all the questions that we have for today. Any other questions that anyone would like to send to us? Please send to us right now. We hope to have a lot of inputs, a lot of discussions going on between us and you guys, the participants for today's webinar. So any more questions, please put your questions on the Q&A box. If anyone else wants a demonstration or wants any more information, I think a lot of information we have not yet discussed. It's interesting to see whether this application can be a lighthouse for other robotics application on the public areas, public spaces, or the factory floors in regards to fighting COVID-19. So if you guys have any more questions, please do ask us right now, because we are open to almost any questions possible.
5 minutes.
We have a 5 minutes slot of time for you guys to send us questions. If you like to question us more about the technology, maybe you would like to ask about the price, you want to ask about you want to ask more about
Video.
any other things that you're interested in. You can send us questions directly. Maybe I don't think that the guys from the operational team on the Air Lab is still there. I'm not sure if they're there or not. If you guys want some more demonstration, we can show to you. We do have another 2 webinars in the following days in Bahasa Indonesia. So if you guys are comfortable in presentations in English today, you guys can attend tomorrow's webinar and Wednesday's webinar. We hope to see you again if you are really interested and you would like to work together with us for this kind of operation or this kind of application. So, I think the guys at the factory, at the workshop floor, is currently trying out the UPC module. Maybe we could hand over the communications to them. Is there anyone? Is there? Oh, I think they're getting ready. So. So I guess they're trying to get ready to do the demonstration. We're hoping that you guys could stay for a while. We can demonstrate to you a lot of other features that maybe we haven't covered yet. So hopefully you can stay with us just for a few minutes. we can show to you other applications such as the such as the disinfectant spray and other methods. So I think Fuad is over there preparing to demonstrate a few other features. Fuad, can you hear me?
Hello? Yes, yes. Can you hear me?
Okay, please do your thing.
Okay, so if we continue to the next feature, maybe. Okay, the next feature is thermal camera. So as you can see before, I just show you the thermal camera on the robot. So as you can see on the UI here, they have a message box and then the thermal camera. So this is I can move and then see there's people inside the rooms. So as you can see, the people inside the room, they have you see they have 36.5 degree. So yeah, it means the normal one. Okay, the next thing is UVC. We try to power on the UVC, right? So I need help for our team. So the UVC need to plug from the port in the AGB. And you can see just plug there. And then plug to the module, which is the UVC module. Okay, just plug there, just like that. Okay, kabelnya di sini. Just like that. So we can control the UVC line from the robot, from the UI also. So press action here. Press action here. Then we can find the okay, so we try to move first. Okay. So AGV with UVC lamp will run scanning all the area. So as you can see there, the green lamp, it means the UVC module is attached successfully to the base core.
So we would like to address some points of this development. So maybe some of you guys are curious about the so-called local content. Yeah. So I would say that the robot is originally designed by our team here, and from the mechanical design, from the functional and the software itself. But to be honest, that especially for the part is maybe like motors and the controller is not coming from Indonesia. Mm-hmm. Yeah. So if I can put this way, then the local. So if there's a question that how many percentage of for the local contents, maybe it is around 75 to 80% because especially for the motors and the sensors and the controller is not produced in Indonesia.
Yeah.
And you know that, but for technology-wise, those controller and the motors are produced by the more advanced manufacturer outside Indonesia. So that's why I think if we are going to make our own motor or make our own controller, if it will not quite possible due to the technology here. But in terms of software, I think we're on the same level and as the country, especially in the Southeast Asia.
Yeah, I think what's very interesting about the development.
Pak Hanif.
Yeah. Okay,
yeah, all right, now I speak a bit. It's very awesome to understand this product. Okay, this is very interesting. So one thing, what I go through this webinar with you. So basically, this product, what I'm seeing is very compact, almost like 6-in-1. It's very modular, whereby you can use a UVC disinfections. You can put in the thermal camera and all this. It's very modular compared to what outside what is using now in the market. Then most important, I just hear that the cost and the selling price is very competitive, okay, compared to fully autonomous. So we are very excited to see this product launch and coming to the market very soon. So it's very great job. Well done.
Thank you very much. Yeah, we do have one more question over the chat room. We see a question from Mr. Aldi Sugiarto. Yeah, he's asking how much is the price for the TOR-I. Maybe we can answer it right now.
Yes.
Okay.
So for the complete set of TOR-I, the complete set means that you got the robot, you got the Matrix sound software, you got the UVC disinfection spray, and the transport track. It will cost below 200 million rupiah. So I think it's around 14,000 US dollar.
Yeah, it's a very interesting question. Thank you very much. We're not shying away from that question. The price we are currently asking for around 200 million rupiah. Below 200 million rupiah, and what you get for below 200 million rupiah, you get all the necessary accessories and also the robotic unit itself. So it's a pretty fair price, all in one. Any applications, any operations that you would need or in the future will need, it is packed in one single robot called TOR-I. So I think that's the very interesting part for this product. As Ricky said, it's very compact, very modular, and we're currently developing for other use cases. So don't you worry. The situation is very dynamic. One day you have one application, the next day you need another application. We're currently developing all the possible or all the needs that will suffice to a lot of applications in the future. So to answer your question, the price will be below 200 million rupiah. So I guess for now, I guess that's all that we could share with all of you. I think all the information that we shared to you, we'll be sharing it again in the next 2 days. So we have another webinar on Tuesday and also another webinar on Wednesday. The difference is that we're going to use Bahasa Indonesia, and also it's not going to be me and Haikal, so you won't be seeing us again. You will be seeing the other team members. So you'll be seeing the head of design and the head of robotics for tomorrow's webinar session. So I guess that's that. If you need the webinar link for tomorrow, we will provide it to you via email, and also we will provide to you via WhatsApp if we have your number. So I guess that's all from Infinity. Thank you very much for attending this presentation. We hope that we could work together with all of you guys. We are very much open to collaborations for any work together plans. We hope we can explore a lot more applications and a lot more possibilities with all of you guys. So thank you very much for today and hope to see you soon. Bye-bye.